Let's look at the first one, the first group of them. It says state the domain of the function using interval and set builder notation. Remember, interval is when you have the parentheses, right? Set builder is when you have this, all right? And so for this one, we are going to go along, domain is x, so we're going to go along. Because this is going with an arrow, there are negative infinity, and where do we come to the stop? That's here at 2. Okay, so this one's a little bit different. We go from negative infinity to 2. Is 2 defined? It actually is, but you do need to tell me there's a break in it because it's not continuous from negative infinity to positive. So we're going along and we are going to -1. Thanks, because I am like all crazy this morning. Negative infinity to -1. It does not include it here. It does include it here, right? And then set builder notation is going to look different. Because it's going to look like it's continuous for set builder notation. Because it really is all real numbers. I mean, this is defined at all real numbers. So x is an element of real numbers. So in this case, this is actually more detailed and actually gives you a better picture of what's going on. But it asks for both, so that's acceptable there. If you wanted to, you could say, if you wanted to be more specific, you could say x is less than -1. Or actually union with, not intersect, and our union x is greater than or equal to -1. You could write that if you wanted to. When it's all real numbers, you actually don't have to do that. But if you wanted to be more specific to show that there's a break, you could. All right, so this one says determine if it's continuous. So that's your first question. Is it continuous? Yes or no? Continuous, not continuous. If it's not continuous, find the x value that makes it not continuous and then classify the discontinuity. So tell me what type. Jump, infinite, point. All right, what type of discontinuity? So the first one, we can see something's going to make this discontinuous. What will make this discontinuous? Yeah, so if you look at the denominator, anytime my denominator is 0, it is discontinuous. Well, where is this 0? Well, x plus 1 is 0 when x equals -1. All right, so I automatically know that this is discontinuous. Discontinuous at the point x equals -1. So that answers the first part. Is it discontinuous? Where? It says find the x value where it's discontinuous. There we go, discontinuous at x equals -1. And then tell me what type of discontinuity. Now, you could have some that have more than one type. You could have a removable and a non-removable, etc. Okay, and so you have to tell me each one. This one only has one. So in order for me to figure out what type it is, I need to then break it down to see if I can remove it, right, point, or if I cannot remove it, infinite, all right? And so, all right, so I'm gonna factor the numerator. Factors of 3 that add up to 4. 1 and 3, so I have x plus 1, x plus 3. My denominator is x plus 1. So can I remove it? Can I cancel it? Yes, x plus 1 and x plus 1 cancel. Because I can cancel, it is removable, which means it's either point or that's actually it for removable. Non-removable has 2. So once it's removable, I already know I have a hole, which means it's point. So I can just say this is point discontinuity, point. So I have answered that it is discontinuous at -1 and it is point discontinuity. Removable is always going to be point. If you can cancel it out, it is point discontinuity. It's going to have a hole there at that point. All right, look at the next one. So -x to the 4th plus 3x squared plus 2x minus 3. Is there a denominator we have to worry about here? No, so nothing's going to make a denominator 0. Is there a square root we have to worry about? As far as the negative in the root? No. Is there anything we can do that's going to make this discontinuous? No, I can put any number in there. It's not going to cause a problem. I can set it equal to 0. It can be 0. That's fine. Just to have a denominator. There is nothing that's going to make this discontinuous. So the answer to this one is just it's continuous. Because it's continuous, you don't have any points of discontinuity.
We don't have to show anywhere.
All right. No, you're just going to tell me. So the things you're looking for a denominator. Denominator cannot equal 0. All right. You're looking for a square root. Square root cannot equal a negative, right? Cannot be less than 0. So no negatives here. If it's just a polynomial with no denominator and no other issues, polynomials are continuous. All right, just regular old polynomials that they're not rational, meaning there's not a denominator. They're not radical, there's no root to worry about. It's gonna always be continuous when it looks like this. All right, let's look at the next one. The next one is a piecewise function. So we need to figure out where it actually has a y value. So we're gonna look at the 1 to see if it's continuous here. At 1, we plug it in here. So if we just plug in a 1, we're gonna use that bottom function. -2 times 1 plus 3. So we have -2 plus 3 at 1, it equals 1, right? Then we need to check, is it approaching 1? So we're gonna actually plug in 1 to the other side to see if it's approaching that. So now we're gonna say, well, is it the same when we plug it in on the other side of it? -1 plus 1 equals 0, all right? These two do not equal, which means that it's gonna be approaching 0 on one side. When it gets to 1, it's gonna jump up to 1, all right? So it's gonna be approaching 0. Once it gets to 1 on the x-axis, it's actually gonna jump and go up to 1, all right? And so this one is not continuous, all right? So this one is discontinuous at 1, discontinuous at x equals 1, and it is a jump. That's what happens with piecewise. It'll approach it, and then all of a sudden you use a completely different function, and it jumps to that new function. Now, sometimes those functions meet, and if those functions meet, it's going to be continuous. But if they don't meet, it's going to be a jump. It's going to jump from one function to the next. Yeah, so the only time you would have something other than a jump is if it was like, x does not equal 0 and x equals 0. Then it's going to be this perfect function, and it's going to just have a point that's taken out of it. But most of the time, your piecewise are going to look like this. Page 3 basically just combines the first page and the second page, and it throws in x and y intercepts, okay? So this is kind of all-inclusive of what you've done on first and second page plus the intercepts, all right? So the first two we've already done. And actually, this is not making you tell me what type of discontinuity here. It's just saying, hey, is it discontinuous anywhere? That's going to help you then tell me what the domain is, which is going to help you with your set builder and your interval notation, right? And then your x and y intercepts are just plugging 0 in for the other guy, all right? So I will say it's easiest to break these things down into factors, all right? That's easiest to factor them. So for the top one, let's just factor these first. If you have a number that you can take out of all of it, do that first. So what number can I take out of all of those? 3. And I would actually take out a -3 because I do not like factoring with a negative in my first position, okay? So -3. And then I have, and I'll just do that up here so we can see it. Then I have x squared minus 3x plus 2. So I'm looking for factors of 2 that add up to 3. Right, -1 and -2 because we want -3. So x minus 1, x minus 2. So that is my factoring for my numerator. Denominator, to factor this, we have -3. So we have a positive and a negative. So we're going to use the same factors, actually, 3 and 1, but one has to be positive and one has to be negative because I want a -2. So which one's negative to give me a -2? +1 and -2. -3, sorry. They multiply to give me 3, and they add to give me -2, right? So I'm going to say we want, up here we have a positive, so they're going to be the same sign. Negative and negative give me a positive. 1 and 2 add up to 3, all right? 1 and 2 add up to 3, factors of 2. Here, I want it to multiply to 3 and add up to -2. So we have a -3 and a +1. I just want to point out we have 2 discontinuities here. Does everybody see that? There's 2 things on the bottom that's going to cause a problem, right? Discontinuities then, it's going to be discontinuous at x equals -1 and x equals +3. Everybody see that? In the denominator, I have 2 problems, a -1 and a +3. Now, if I were asking you what type, all right, these would be infinite, both of them. I can't cancel this as a different sign. I can't cancel this. So these would both be infinite discontinuities, by the way. So if it asks you what type, these are non-removable. They're infinite, okay? They're infinite discontinuities, okay? If I could have canceled one, I would have had 1 point and 1 infinite. That's possible too, but neither one of these will cancel. So just pay attention to that type because you are eventually going to have to do that piece of it too. All right, so discontinuous at those. I've answered one question. This also helps me with the domain. These are the only 2 places on the real number line that I can't have an X. So my domain is literally going to be just everything but those 2, right? So for my domain, I can say, well, X is going to be all numbers except it cannot equal -1 or 3. So my domain is going to look like that. If you did interval notation, because it does ask for both, you're going to go from -infinity to -1. It doesn't include -1. From -1 to 3 does not include 3. And from 3 to infinity. All right. And so that's my domain. I'm basically just saying it can be anything except -1 and 3. So by finding my discontinuities, I actually helped myself find my domain, okay? My domain is anything except -1 and 3. So if you were to see this on a graph, you would see that there's a break at -1 and -3, just like on the first page. If I were to give you a visual of this graph, it would go off to infinity at -1. You'd have some type of parabola probably in between, and it would go off to infinity at 3 as well. And so if you were to look at this, you would be able to see, okay, you can't have -1 or +3. All right? So discontinuities leads you to give me the domain. All right? And so that's what you need to do next. Discontinuities and then domain. The last thing it wants are X and Y intercepts. Now, the Y-intercept's easiest to use up here at the top, right? Because we're just plugging in a 0. So for the Y-intercept, I would say just go to my original Y-intercept, just plug in a 0, plug in a 0. So I'm going to say -3 times 0 squared plus 9 times 0 minus 6 over 0 squared minus 2 times 0 minus 3. So the first 2 cancel out, and I'm left with just -6 over -3, which is a +2. So my Y-intercept is going to be when X is 0 and Y is 2. 0, 2 is my Y-intercept. For my X-intercept, I want to set it equal to 0. In this case, only the numerator. The denominator cannot be 0. So set the numerator equal to 0. All right, we have already factored the numerator, so that's very simple. We're going to set this guy equal to 0. Now, that means each factor has to be equal to 0, right? This factor can never be equal to 0, so we throw him out. All right? Where is this guy 0? At x equals what? 1. Where is this guy 0? At x equals 2. I have 2 x-intercepts. I have 1, 0, and 2, 0. Those are my x-intercepts. So once you that's why I start with factoring. Because factoring is going to help you with your discontinuities. It's going to help you with your domain. And it's going to help you with your intercepts. Okay? This just means plug it in. Okay? So they've given you a function. And then they have some function with parentheses. Whatever's in parentheses, they want you to plug it in. So if it's a number, you just plug in the number. So we're going to say 3. And instead of a, we're going to write that -4 that they gave us. Plus 5. And then just do order of operations. 3 times -4. Plus 5. -7 is your answer.
Yes.
All right. So for this one, it is not telling me to plug in a number. It's telling me to plug in z squared. All right. We are going to do the same process. 4. And instead of t, I'm going to write z squared minus 2. So we're going to just get this. So you're just deciding exponent, even or odd, leading coefficient, positive or negative. This is the chart. If it's even, they're going the same direction. Even and positive up, even and negative down. If it's odd, they're going opposite directions. It's either going continuously up or continuously down. Then you're just going to say, okay, I have odd, negative. That's right here. This is odd, negative. So as x was going this direction, as x was going to the right, the function itself was going down. As x was going to the left, the function itself was going up. And I'll rewrite this so you can actually see that looks like a negative. This should be as it's going to negative infinity. All right? So for x, positive infinity is right, negative infinity is left. For y, positive infinity is up, negative infinity is down. That's all you're doing. So as x was going to the right, y was going down. As x was going to the left, y was going up. This is what you're telling me here. Your answer is this guy right here. So it's going to equal that for that and that for that. That whole thing is your answer. You have to tell me, as x is going to the right, this is what y is doing. As x is going to the left, this is what y is doing.